Last week we did categorical data using the chi-squared distribution. And this week we're going to use the F distribution, which I had mentioned in a prior lesson. We were doing the F because we were doing two means back then. So if you want to do three or more means, then you're going to use, it's called ANOVA, analysis of variance. This video right here gives you the comparison between one-way and two-way. So if it just says ANOVA, that means one-way typically. So one-way and two-way mean number of factors. Okay, so basically, if it's one factor here, like they're just different groups, right? That's a one. That's just an ANOVA. If you have two ways, right, two different factors, then it's a two-way ANOVA. Okay. All right. So we'll do the first one here. So basically, F here is the between group variability and then within the group variability, and you have two different degrees of freedom. So D sub 1 and D sub 2 is what the book typically uses, not always 1 and 2, depending on what book you use for the degrees, because it's different degrees of freedom for each of these, essentially. And that's just how you figure out the variability, the two different formulas between groups and within groups, basically. Okay, it's the sum of squares for the between groups, and then the average of the variances for within groups, basically. So the hypothesis is basically, or the null hypothesis is all the population means are the same, and the alternative is at least two of the population means are different, right? Because you only need two of them to be different, or one of them to be different from something else, basically, for it to fail. So there would be a secondary step where you would go back and do each individual subgroups. Like if there's three of them, you do, group 1 compared to group 2, group 2 compared to group 3, and group 1 versus group 3, using the T distribution. But that's a long process. We're not going to do that. We're just going to say that they're not the same, and that's good enough for what we're doing. We don't do that. So basically, and they're always right tail also, basically. Okay, so it's always a right tail for all ANOVA, basically. Okay, so let's say we have three groups. We have U.S. students, Canadian students, and Mexican students, and they have a vertical jump in centimeters here. So we want to know if these three means, if there's any difference in the groups, essentially. Obviously, that means these samples be different, but in the populations, are they essentially the same? Okay, so let's go to our class here and open up a spreadsheet. Create a blank one. And come on, load. Load. Okay, so we'll right click down here and we'll rename this one way. One way. The other one will be two way, which will be the second video. Rename two way. Alright. Okay, so for the one way we have group 1, group 2, and group 3. We don't really need to differentiate which one's US, Mexico, or Canada. It doesn't really matter. Okay, so the numbers, I'm just going to copy in. There we go. There's our numbers. There we go. Okay. So group, well, let's actually go down a box. Actually, we'll say group 1, group 2, group 2, and group 3. And we need the count, the sum, the sample mean, the sample variance, and the total, or grand mean, they call it sometimes, or total mean. That's what we're going to need. Okay, so we'll center those out, bold them, yellow. These ones I think we're going to right shift them. Bold and yellow. Okay, and then we can box that up. Okay, so equals count. There's count. These should all just be 16. Okay, or 15, sorry. Count. Count. There we go. Okay, we have to add them up. Equals the sum of these ones equals the sum of these ones equals the sum of these ones. There we go. Okay. And then equals the sum divided by the count is the sample mean for group 1. Drag that down. There's the sample means for each one, which are different, but we want to know if is the population different. These are only samples. Okay, so variance dot sample. So group 1 variance, variance dot sample, group 2 variance, variance dot sample, and group 3 variance. Okay, so we're going to compare that to the grand mean, they call it. It's not the only thing. Some books call it grand mean, some books don't. But let's see. Average, right, of all together, basically. Right, so groups compared to the overall average. Okay, so we'll go down to here and we'll say ANOVA. We'll bold that, box it, center it. We'll make that blue. And we need the source of the variance. And we'll put those together, merge them. So we need between groups, groups, there we go, and within groups. Okay, now we gotta merge those. Merge, and merge, and these two will send to the left, I guess. Bold, yellow, box. Okay, so we need degrees of freedom, the F, capital F, sorry, the P value, and we'll do F critical. We don't need F critical, but we'll take a look at it visually. Okay. Let's center those out. Let's center those out too. Send them out. Yellow, bold, box them. Oh, why did I do that? That was, I'm sorry. Let's copy. Sorry, I did that. I don't know why I put them up there. Degrees of freedom, F, P value, and F critical. Okay, I don't know why I did that. I was on the wrong line. Boom, 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 boom. There we go. Now we can box these up, I guess. Okay, so let's drag our formulas over here so we know what we're talking about. Let's go to our notes, actually. We'll just copy this for our F, because we know that. That's going to go there. We'll need this afterwards, right? And then we need this right here, copy, paste. Oh, there we go. Those are the things that we need there. Okay. So between groups is right here. Degrees of freedom is G minus 1, the number of groups minus 1. So it's 3, equals 3 minus 1, because there's 3 groups, right? Group 1, 2, and 3. Right? I'm calling them group 1, 2, and 3, but it's actually US, Mexico, Canada, or US, Canada, Mexico. I forget what the order is, but it really doesn't matter. Okay, and then the degrees of freedom within groups, right, is the number of observations minus the number of groups. So the total number of observations is 15 times 3, so that's what, 45? Minus 3 groups, you get that there. Okay, so our variance here within groups is add them up divided by the number of groups. So that's within. Okay, so equals parentheses plus and then divide by the 3 groups. And there is the within group, which is this formula right here. This one's a little bit tougher. The between groups, because you notice it says y sub 3, y sub 2, y sub 1. Those are the individual groups, and the y bar is just the overall mean, essentially. And the problem is this n in the beginning. That tends to get done incorrectly because you need a second set of parentheses when you actually do the formula. Okay. And people get it wrong because they'll say it's 45. It's within each group, so that n is actually 15 in this case, since there's 15 per group, because each one of these is a group, basically. So what does it say in my notes here? I probably should have specified that, huh? Okay, but then is the group number, so... Okay, anyways. So equals, parentheses, so we're going to put the 15, because it's 15 per group, times, and then we want a second set of parentheses for all of these individual, which we only have 3 in this case. Okay, so the first one is this variation, this mean minus, that's the group mean minus the grand mean squared, plus the second one, which is this mean minus the grand mean squared, plus, and then we have the third one, minus the grand mean squared, and then close paren, right? For that there, because it's all being multiplied by 18, and then close paren again for the whole thing. So that's the whole numerator, divided by, well, the formula says g minus 1, so we're not going to put g minus 1. We're just, since it's 3 minus 1, we're just going to put the 2, because otherwise you need another set of parentheses. So the biggest mistake there is people lack of parentheses to get the order of operations correct. Okay, so I think we're good there. Maybe not. What did I do wrong here? Something's wrong. What did I do? Oh, why did I turn 18? That should be 15. How did I do that? I must have deleted the wrong thing. Okay, now it's right. Alright, I don't know what happened there. I said 15, but then I put 18. Okay, so we need the f value. So if you look at the f value formula, it's between group variability divided by within group, right? So equals, so between group divided by the within group variability. And there's our f value. So the p-value is always a right statistic in this. So f dot distribution right tail. Okay. This is the x value, which of course is f in this case, comma, we have degrees of freedom. This one, that's 1, and that is 2, close paren, right? If you don't remember right here, degrees of freedom 1, degree of freedom 2, right? Between groups and within groups. Okay, that's what those groups are, will vary. So there is my p-value, right? Okay, so typically if it's not specified, you use the Fisher rule. So 0.05, so clearly this is bigger than 0.05. So you would not reject a null hypothesis. So if we did a little visual, we can do f dot inverse right tail, right? 0.05, comma, and we can do the degrees of freedom. Or equivalently, we can do f dot inverse, and don't do a right tail, do 0.95, comma, degrees of freedom, comma, degrees of freedom. Right, and get the same answer. So visually, what do we have here? Let's see here. Oop, that's the wrong thing. We want this right here. Okay. Scroll down a little, pop it up. So remember Z and T are the symmetrical distributions, and chi squared and f are the asymmetric distributions, right? So we have one that is asymmetric right here, right? So we have 0.95 or 0.05 as far as the area goes, right? Right. So if I did the right tail version, it's going to give me this. I'm using 0.05. If I just do the regular left tail, yet put in this, which is why I got the same answer twice, right? So this is my F critical right here, which is 3.219 dot dot dot, right? Depending which one I did there, it's the same thing either way, correct? Okay, but RF is 1.6, so RF, this is our critical, right? F critical was 1.69, right? So basically we didn't make it into here. Also, this area is more, right? So this total area right here is the 0.1955. So this is the expected range of samples, basically. So our samples basically fell within here. So we cannot argue that there is a difference within the means of the groups, basically. So if you did your hypotheses, right? So we'll copy this here. I'm not going to write these out formally, right? So, so we'll say the USA, Canada, and Mexico. Right? So, and then this is in centimeters. Right? At least two of the population means are different. So, our answer, obviously, we get rid of this. As to which two are different, or we don't. Well, we're saying they're all the same. So the p-value is greater than alpha, which we're going to use the default Fisher rule, right? So do not reject the null hypothesis, right? Okay. All right. There is not enough evidence to reject the null hypothesis. Our samples are not significant, meaning they're expected, right? So there is not enough evidence to conclude the vertical jump heights of students in the US, Canada, and Mexico are different. Right? So we have to assume otherwise that they're the same. Okay, so that's the end of part 1.